Last time we looked at measures of center, where we could say the typical member of the population should be around here. That's half of the picture. We know it's typical, but how spread out is the population? If you say the average person or the average height for people is mean, median, or mode 5 feet 6 inches, that's fine. But does that mean the population is between 5 feet 5 inches and 5 feet 7 inches and everyone fits in that range? Or is everyone between 0 feet and 9 feet? Are they that spread out, or are they that consistent? So we've got one number in the measure of center that tells us this is typical, and now we need another number that tells us this is how spread out the population is. And we have 3 candidates for that as well. 2 that are easy, 1 that is more difficult. The one that is more difficult is the one that's going to tell us the most. I'm not positive we're going to get to that in this video, but if not, it'll be the next one. So the range and the interquartile range are easy to calculate and very closely related to each other, but we need to talk about another topic first, which is a quartile. What is a quartile? If we divide our data up into 4 equal pieces, each of those is a quarter of the data. So here, same thing we looked at last time, we have 10 data points. So if I divide them in half, I've got 5 down here and 5 up here. If I divide each of these halves, 4 was in the bottom half, so now I've got 1, 2, 3, 3, 4. If I take the middle number here, that divides that data into 2 halves. And if I take the middle number here, that divides the top half into 2 halves. So I've got my quarters. And those division points, those breaking points between the quarters are what we call quartiles. And we name them by how many quarters of the data are beneath that in the list of data. So the bottom number here, we would call Q0, the 0th quartile, because nobody is below that data. This guy, the number here, we would call Q4. We'd also call that the maximum number, because the entire data set is less than or equal to Q4. So all 4 quarters of the data. The median that we talked about last time, that's Q2, because 2 quarters of the data fall below. This one's called Q1 and this one's called Q3, right? 1 quarter of the data is below, 2 quarters below, 3 quarters below, 4 quarters below. So those are the quartiles, and they're going to be important in a topic that we're going to do a couple videos from now called the 5-number summary. But here we kind of need to talk about them too, because to calculate the range, we're going to subtract Q4 minus Q0, the maximum minus the min. The range is how far apart are the biggest and the smallest members of this data set. So here, in this example, that's going to be 8 minus 1 is 7. Okay? Now, people's intuition tell them that range should be a range of numbers. And that's true, not in statistics. The range is how far apart are the ends of this range of numbers. So the range is not from 1 to 8. The range is 7. 8 minus 1. Okay, the range is a single number, not a range of numbers. The interquartile range says the middle half of the data is this spread out. So the range says from the smallest to the biggest of the whole set of data, that distance is 7. But if I look at just the middle half of the data, I leave out the ones on the ends, look at the middle half, the most typical of the population, they're not quite as spread out. 7 minus 3 is 4. So if I look at on the number line, this whole set of data, it takes up 7 full units on the number line. If I say just the middle half, the most typical of the data, that's going to take up 4 units on the number line. So total spread out is 7, half spread out is 4. We are absolutely not getting a standard deviation here, so let me get rid of that ugly formula. And let's look at one more example here where I change the number of numbers on us. Let me take that 8 back away. We'll go back to what this data set was the first time. So The minimum is going to be Q0 still. The maximum is still going to be Q4. The median is the one in the middle, right? If we have an odd number of numbers, then that actually is one of our middle numbers, and that is going to be Q2. And we do not count Q2 as being in the top or half bottom of the data. So now if we look at the bottom half of the data, Q1 is going to be the midpoint here, which is going to be 2.5. Because we have an even number in that half of the data now. And if we look at just the top half of the data, we've got 6.5 here as our Q3. Okay? So our range is not going to change because our top number is still the same. So it's still going to be 8 minus 1, or 7, just as spread out as it was before. But now our interquartile range, the range of the two middle quartiles, is going to be 6.5 minus 2.5, which is going to be 4. That's a horrible example because it didn't change at all, but I think it illustrates how we find those numbers. And we're not done with that. We're going to come back to finding the quartiles when we look at the 5-number summary. Next, standard deviation, you're going to love it.